The opinions expressed are those of the participants and do not necessarily reflect the official positions of the sponsors, advertisers, or presenters. Advertising does not imply endorsement by the sponsors and presenters.
Hey guys, and welcome back to the Lighting Controls Podcast. We have another fantastic episode for you today. We have two titans of industry who have been on the show before, who have come back to talk to you guys about something else today. But before we jump into the conversation, let me take a minute to remind everyone, today's episode is presented by the LCA, the Lighting Controls Association.
And it's financially supported by the National Association of Innovative Lighting Distributors, or NAILD. Check out our website, lightingcontrolspodcast.com. We've got all of our episodes, a news feed, a merch store, Council on Lighting Control startup and integration and training opportunities coming up, as well as this is an unsponsored episode, so we're just going to mention our companies that we like to do for our day jobs. I have my own company, Penumbra Controls, where I give a lot of education, outreach, and guidance to people who want to learn about lighting controls and improve their knowledge and expertise. And Ron, do you want to talk about Port?
Yeah, and here at Port, we are a two-facet company. We have our production side of the company that goes out and does live events and all the big production work, corporate parties, things of that nature. And then our installation and integration side. We do a lot of schools, churches, architectural color changing, pretty much anything you want to do, we can help you achieve, and we're here to help.
Awesome. So check us out if you want to get involved in lighting controls and need support. But until then, so let's get into this conversation. I'm going to first have you gentlemen introduce yourselves, and then we're going to get into the topic at hand, which this is going to be a shorty episode, but we're hopefully going to be covering some really interesting topic here. Javid, do you mind going first, just giving us a quick breakdown on who you are and what you do?
Not at all. I'm Javid Butler, and I'm now with Goddard Design LLC, which has about a 35-year history of lighting control test equipment. And we are looking forward to continuing with the existing products like the DMXster 4A and the Mini DMXster, and adding some new innovative products for any sort of lighting control testing. So look for that over the next year or so to start coming out. And we're very excited to support this podcast and all of the organizations that are behind it.
Awesome. Thank you, Javid. And Robert, do you mind just giving us a quick breakdown on what you do as well?
Sure. Yeah. Thanks so much for inviting me back. I love chatting with you guys. I've been doing this for 35 years or so. I started at the Canadian Broadcasting Corporation, and then I founded a company called Cast Lighting, and we were known for bringing out a concept and an idea called WYSIWYG. And then from there, I went to work for Roscoe Entertainment Technology and Genlight and Verilight and Strand Lighting and Horizon Control. And all of that, I didn't actually change jobs. Those were all the same company. They just kept getting acquired. And then finally, the company I was working for, Horizon Control, was acquired by Acuity Brands back almost 14 years ago. And they put me with the Pathway Connectivity Engineering Group. And now I'm a product manager for Pathway Connectivity and have been for the last 14 years. So
awesome. Well, thank you both for joining us here today. And, I think what's really interesting is the topic that was brought to us from Javid, who had been kind of circling the online forums out there. And really, it is a topic that is worth discussing, which is proper cable and wire for your DMX512 communication lines, not just raw DMX, but also streaming ACN or other platforms for transporting DMX. But Javid, do you mind just kind of talking through what brought this topic up in your mind when you first approached us with this?
Absolutely. And I think it was actually Robert who had been following the online forums and had posed that to the E1.27-2 Task Group. So let's just start with a little background here.
Yeah, before you jump into that, do you just mind explaining that task group and what they're responsible for?
I was just getting there.
Perfect. Okay, great.
So I think a lot of people are familiar with DMX512 and may also be familiar with streaming ACN. both of those, and also remote device management, RDM, all of those protocols were developed and are maintained by the Entertainment Services and Technology Association, or ESTA, which is an American national standards making organization. They are authorized by ANSI to develop standards. And I won't go into the whole details of the process because I believe the point was to wake people up and not put them to sleep. But anyway,
And we also had boring process.
We
it is
did
a long,
have
boring process.
ESTA on to talk about Plugfest, which is coming up soon, anyways. So we do have an episode. If you want to learn more about ESTA, please go through our historical archives. I believe it's one of the more recent episodes, based on this episode. So definitely check that out. But yeah, I mean, we're talking about a task force that's part of ESTA. That's responsible for
cabling for DMX512. And originally, DMX512 cabling was written into the 1986 and 1990 revisions of the standard. And where we were working on the revision that was first made an American national standard and published in 2004, there were some complications and some discussions about how to approach that. And so ultimately, that was the only point where we couldn't achieve consensus within the entire body. So we took those technical issues out of DMX512 and moved them into a new set of standards, which are known as E1.27-1 and E1.27-2. And part of the problem that we had with keeping them in DMX512 is that portable cables and permanent cabling have very different requirements. And by breaking them out, we were able to create separate substandards, -1 and -2. -1 is for portable cables and -2 is for permanently installed cables. So we were able to resolve that technical challenge that had prevented it from being published as part of DMX512A in 2004. And the cabling standards were first published in 2006. I want to say 2006. It's been a few years. And
the document I have here is 2009, and I'm not sure if that was
2009. Okay.
Yes. Yep. Our 2019 is the one I actually have in front of us, but the original was 2009, I think.
Which would make sense, given that we have a 5-year cycle of renewal. And that's part of why we wanted to talk to you right now, because we are in the process of reviewing and updating E1.27-2, which is the permanent cabling standard. And over the years, there have been a few relatively minor changes, but they are ones that generate an inordinate amount of discussion and questions. Yeah. And so maybe with that background, Robert, if you could talk a little bit about some of the questions and concerns that you've had come to you.
So we're talking, and we start throwing out the numbers like they come off our tongue, but the E1 is like the ESTA group of protocols or standards, and the Control Protocols Working Group, which Javid and I have been sitting on for 20 years, are responsible for E1.11, which is DMX, 20, which is RDM, 31, which is sACN, and then 27. And you're like, what happened to all the ones in between? Well, sometimes they go to the FOG group, sometimes they go to the Follow Spot platform group, the dance floor group. So lots of different standards. So it just is the next one that comes in it. And E1.27 was specifically about communication on the RS-45 layer. So we're not talking about Ethernet at all. And that's the confusing bit, because the next thing I'll say is E1.27-2. E1.27-1, as Javid said, is for portable. So this is essentially stuff with XLR connectors on the end. XLR 5-pin.
5-pin. 5-pin.
Full stop. Enough said. And then E1.27-2, which is for non stuff you're not going to run over with a forklift or wrap or do anything. So permanent installations, which is DMX with the advent of LEDs, I'm really dating myself, and dynamic lighting, architectural controls. Almost every single building that gets built now is obviously using LEDs for white light, but then there's always, the pizzazz. They need RGB luminaires to do some sort of dynamic lighting on the front of the building, or chandeliers or sconces or whatever it is. And there's no need for these things that are never going to be connected more than once to go through the expense of having an XLR 5-pin connector on the end. So we said, we could talk about the connectors, and that's a different topic, but we want to talk about what is acceptable for the transmission of RS-485 multi-drop and differential protocol, or differential electrical signal. Don't say protocol, Robert. And what we found out is category cable, starting with Cat 5e, has a twisted Cat 5. Is it? Well, I think I said Cat.
Way back when you could still buy Cat 5,
yes,
we did start with that, but it very quickly got to be just Cat 5e. Yes.
That's what I wanted to punctuate. You can't buy Cat 5. We say Cat 5. Now it's Cat 5e, Cat 6, Cat 6a, Cat whatever. Yeah. So the very first versions of category cable was 4 twisted pairs. And the twist pattern was superior and more consistent than what we were using for RS-45 running at 250 kilobaud, because we were running 10 times that speed on Ethernet. So people more clever than myself in the task group, did some tests and oscilloscopes and looked at it, and they said, RS-45 travels exceedingly well for 1,000 feet or more on category cables with the twisting. And as I said, there's the orange pair, the green pair. I didn't say, but the orange pair, the green pair, the brown pair, and the blue pair, they're each a twist. So there's the brown, brown, white, green, green, white. And we're like, okay, so we have 8 conductors. We only need 3 for DMX. So what do we do? So we said, okay, we'll take the orange pair for data plus and data minus, and we'll just grab another one to be the data common, which happened to be brown, or brown, white. And then shielded category came out. And this is where it all fell apart. Because we were all very used to, and please, it's been a while since I said it, is it Belden 9773? Is that what DMX cable typically portable?
72, isn't it?
So portable tends to be different at this point. There's ETC that likes Belden 9729. There are other manufacturers that like 9741 and also 9829. So 9729 is 2 twisted pairs with an individual drain wire and a foil shield over each pair. 9829 is 2 twisted pairs under a common foil shield with a drain wire and a braid shield overall. And they have different characteristics when it comes to that. But I'll let you keep going, and then we can come back to fun with shields.
So it's sort of we were just thinking that we were historically using the shield as data common, which is very important. You can't just have the 2 wires. You need a reference point. And that reference point is an electrical reference point. It is not an electricity earthing ground reference point. Right. So there was a lot of debate about, if your data is going to be on coming from a transmitter, should it be earth ground at that point for RF immunity if it's the shield, or if you have a separate conductor that is inside of the shield, that conductor should be the data common and should not be earth ground. And And what happens, we got very used to using these Belden numbered stuff, and there wasn't the extra conductor, so we used the shield as the common.
Mm-hmm.
And then category cable came out, and specifically in Europe, the authorities having jurisdiction there said, oh, well, you've got this RF shield around this cable, it needs to be earthed at both ends. And that's when electronic engineers freak out.
Yeah.
Because having the potential for differential ground loops and all the rest of it, and again, I can't stress it enough, data common and earth ground are completely different. They're apples and oranges to each other.
Right. And so just to distill what you're saying here, Robert, for the people who aren't too up on cable and all of this stuff. So basically, the original RS-485 cable that was used for DMX had a shield surrounding the two wires that are twisted together, and that shield was being used as the data common between devices, which is just a way of making a reference point for that electrical transmission. It's not actually grounding. It's, there might be some shielding that goes along with it because it's creating some buffer in your cable, but at the same time, you're also using it electronically for a purpose. And if you were to connect that to earth ground, you would start causing some potential mishaps because you're now tying to other electrical components and other electrical things in your building to a degree. I mean, yes, it will,
Let's let the electrical engineer make some comment.
Yeah,
here.
go for it.
So first of all, when using those cables, a lot of times the drain wire of the shield was the only third conductor available for data link common. The E1.11 DMX512A standard does also specify that the preferred topology is to earth ground data link common at the transmitter and only at the transmitter. And that's a reasonably good practice because that is essentially creating a star, so long as that data link common is not earthed anywhere else in the system.
You don't accidentally create a loop.
Exactly. And when you do start connecting, a lot of times people think, well, ground is ground. I mean, you look out the window and there's ground, right? But
terra firma.
Terra firma, exactly. But inside of a building, you have all kinds of structure that has resistance. And the reason that it has resistance is because most of the built environment is not maintained at absolute zero. So, and frankly, I would not want to be in a building at absolute zero because, might be hard to move, chance of shattering, things like that. See any of a number of science fiction movies about what happens to the human body at those kinds of temperatures.
At this point in time, we should also note that Javid writes science fiction.
Yes. Anyway, the point being that there is resistance in the structure of a building, regardless of how that ground is run. And that means that you can have a potential difference, a differential voltage between different ground points of the building. That gets even more complicated if you have a building that is fed from multiple sources. And large buildings or campuses of buildings, they can have multiple electrical fields, which each have a separately derived ground. And if the shield of your DMX cable is the connection point between two grounds that have a different voltage, there will be current through that shield. Now,
and this is where I just like to say, remember festivals where there's generators for the front of house and then snakes that go to the stage with different generators. You could just well imagine there's almost zero chance that they're going to be at the same potential.
Absolutely, yeah. Well, the most common case is that you have a little bit of current flow and that creates some interference. So now that shield that is supposed to be protecting the data inside the cable is now the source of interference with the data in the cable because it's carrying alternating current. The worst case, and this has happened on occasion, and Robert and I both know some people who can tell some really entertaining stories, is that your shield is no longer a shield and it is more like a fuse. And, you know, DMX512 really, when you're running it over copper, it's not wireless, folks. So if you have huge ground loops in the shield that causes the cable to evaporate, you have lost all of your DMX512 connection.
Yeah, the shield's going to melt at a much higher temperature than the stuff on the inside, which would just work.
Yes. Yeah. So,
so basically, the summary point here is that you don't want to create that ground loop.
You do not want ground loops. Yeah. I mean, when the best scenario is flickering, yes, you do not want to create ground loops. And that is why the E1.11 standard specifies that the preferred topology is to only earth ground at the transmitter and to be floating or isolated at all of the receivers. There's a very good reason for this. And we've just talked about those.
And fixture manufacturers that are paying attention, that means if you put a multimeter between pin 1 on the male or the female DMX connector and the metal of your moving lights, there should be infinite resistance. That's not
in the compliance standard, we specify megohm range just because we had to plug in a number. But yes, you should not read continuity between the chassis of the fixture or the dimmer or whatever device you have and pin 1 of the XLR connector. Should not have continuity there. If you do have continuity, then you are going to have a ground loop, most likely. And maybe it'll be a minor ground loop that won't cause you too much trouble. Maybe not. And so...
worst case scenario, could give you a shock.
It could give you a shock, yes. Absolutely. Well, or evaporate. Evaporate is probably the absolute
it's probably the worst case scenario, yeah.
Evaporating metal is generally considered to be pretty bad, yes.
Pretty hazardous.
And this has happened on occasion. This is something that can happen. Anyway, E1.27-2 continued that in the language that we put into the standard for the one that was published in 2009. However, because at the time, a lot of AHJs in Europe were requiring that the shield be grounded everywhere, that created some language that we had to kind of compromise. We basically said, in effect, check with the local authority having jurisdiction, right? If they're telling you have to ground the shield everywhere, then we're not going to tell you not to, because, the AHJ is a much bigger stick than, a bunch of volunteers at ESTA. So we put in that language, and if you are using shielded twisted pair category cable and properly connecting only the orange and brown pairs, strictly speaking, that wouldn't matter because the shield is not connecting anywhere except you do connect to earth ground at the transmitter.
But old habits die hard. and people that had been using the shield on our old DMX cable are thinking, what do I do with this foil thing? I know, I'll shove it in pin 1. And that's where it all fell apart. And the requests I was getting from our customers was, I've read the standard, it doesn't say what to do with the shield. There was
We
It
were
takes a long time
deliberately
to edit.
obtuse.
Yes, it takes a long time to edit these documents, so you might be editing the first 6 paragraphs, and then 6 months later you get together and you edit the next ones, and then we're supposed to read it all and all the rest of it. But if you really went through it with a fine-tooth comb, the way the 2009 document is it didn't contradict itself, but there was an omission that was there, I think, because we were just not willing to attack it in 2009. And now we're thinking, okay, there's enough people asking, what do I do with this shield? And when you ask the practicality of people, if you ask me, I'd say don't attach it to anything. Just let it float. Use brown. Use orange and orange, white, and brown. And specifically, there's another conversation. Do you use both brown or just one brown? And I'm of the opinion you use one brown, not two. And this gets into a discussion about capacitance and very quickly gets into math that is far above my head. But it will work just fine if you pick brown, white, and then the twisted pair. Because, again, it's only in the data plus and data minus with the differential. The other conductor, it doesn't really matter. It's just got to be a reference.
All right, I have 2 follow-up questions. So how did this affect the manufacturers who were using orange and green for DMX transfer? How did that play in, and how did conversations with those manufacturers go when the standard decided, or when you guys decided the standard needed to be orange and brown and not orange and green? And then secondly, you mentioned the compliance standard, and how does that all tie into this as well?
You want to take the first half of that?
Yeah,
and I'll take the second.
Yeah. So power over Ethernet is a layer 1 negotiated communication between a power sourcing unit and a powered device. So you can't just stick multimeters in on pin 1 and 6. I can't remember what it is, and find 48 volts. The switches that supply the power sourcing units should wait for a negotiation to happen. But in the early days of power over Ethernet, there were power injectors, which were, some of them were smart and some of them the early ones were very stupid. So they basically just applied a voltage to those pins. And I believe the pairs that were commonly used, depending if you use the B standard or the A standard, were on the green. So if you had a non-compliant power sourcing unit, then it would be you would actually have voltage there at the time. So we didn't want to put that down a data signal. So I believe the preferred connections was to use the brown pair.
But based on what you're saying, I mean, modern technology protects against you accidentally cooking your equipment.
Yeah.
Yes, in principle, but the challenge with trying to make something completely foolproof is that it is easy to underestimate the ingenuity of complete fools. So, given
there's a phrase I heard recently that you can work to make something foolproof, but they'll just make better fools.
Yeah, that too. So the challenge is that people will come up with creative ways of getting 48 volts into a system, and if you're talking a $50 router, if you're talking a $50,000 lighting console, right. So that was the logic at the time, and now, of course, it's been enshrined in the standard for 20 years. So unless ISO decides that they're going to change the wire colors on the pairs and category cable, which, to paraphrase Arlo Guthrie, was not likely to happen, and we don't expect it. Okay, no Alice's. Oh, one Alice's Restaurant
Yeah.
fan.
I
So anyway, it's orange white for data, brown for data link common. You must have data link common. Must have data link common. And in case I was at all unclear, you must have. Yeah, go ahead.
And speaking about wire too, it must be one of the RAS TIA 485 standards or one of the category standards for Ethernet. And the number of times I've seen, architectural LED drivers that use, in Canada we call it TEW, which is just your stranded 12 gauge wire that is absolutely not twisted and sometimes goes tens of feet inside of a fixture. That's not cool either.
It's not.
And you wanted to talk about, Ron, you said about the recommended practice or the compliance.
Let me just
standard.
Make one other point about that wire, because part of the reason that we broke out cabling from E1.11 is because the specs for category cable and for RS-45 designed cable are different. And in fact, when you look at specs for category cable that is being used for Ethernet, it has a 100 ohm nominal impedance. And people might look at that and say, well, why are you saying it's okay to use a 100 ohm cable for DMX512? Well, the answer is that normally category cable is not specified for DMX512, so it's called nominal 100 ohm, which it is at Ethernet speeds. At DMX512 speeds, its nominal impedance is around 120 ohms, and so it is just about perfect for using with DMX512.
I think I just read something the other day. You take the bit rate and the distance, and it should not exceed 10 to the exponent 8. And that can get
some rules of thumb. Yeah. So with regard to DMX512 compliance, the compliance standard does have specific tests, and that includes some static tests of resistance as well as some powered tests for voltage. And so that does include a test where you are required to test the product and ensure that it has a very high resistance between data link common and chassis. We also put in a little diagram that specifically shows where those test points are. So anything that is certified as ANSI E1.68 compliant should have that isolation already built into the product. And if it doesn't, then you definitely want to make a posting about that on social media, because they're claiming compliance and they aren't. So the standard is available for free download from esta.org, esta.org. And
we'll have links to both E1.27 as well as the compliance standard so that people can access that in the description.
Wonderful. But those tables are right there in section 6. And so anybody who's interested can look at what the values are supposed to be and check their own gear and see whether it's compliant or not.
We're almost out of time here. So, go ahead, Robert. What were you
I just wanted to say it's difficult to wrap this up without talking about the connectors and the difference between solid core and stranded cable and how things go. And I'll tell a quick story about why we at Pathway Connectivity, who make a lot of permanent installation DIN mounted devices, changed to an insulation displacement contact connector. This is a 6-pin one, but we make the 3-pin too.
Yeah, so for people who are listening and not watching, we're looking at an actual connector that Robert's showing us, an IDC connector, which basically uses this push component that snaps the wire into place so that you can just connect it quickly to a terminal.
And 2 little knives cut and displace the wire, but don't.
So you don't need to
strip the insulation.
wire.
Yeah. So it makes installation really good. But there's a funny story about this is that originally we had compression screw connectors and people were starting to use category cable, solid core category cable. And it was the Staples Center in LA, I believe. And the trick with that is nobody takes a torque wrench with them, right? So if you get an excited installation technician, they go tight and probably likely crack the 22 gauge wire. And
I've never done that.
Everything was working fine until Metallica came in to do the first concert, and they had all these concussion pots and shake the building, and a lot of these very fragile components broke off, and all of a sudden a lot of the DMX wasn't working. So we learned our lesson on that, and we're like, okay, if we're going to start pushing, and I'm a big proponent of pushing E1.27-2 for permanent installations. I would highly suggest don't use compression screw connectors. Find insulation displacement ones, and they really will make you won't be going back near as often to debug these things.
I agree, because for people who don't install wires, just so you know, category cable has very thin wires inside of them, and trying to manage that with a screw terminal versus an IDC, it's a lot more hassle. So definitely worth the consideration.
IDCs are also significantly faster for installation.
Yeah.
So anyone in the installation market, I can't tell you how much time we have saved using cat cable and IDC.
So just a quick note, because one of the advantages of using category cable is that most of the time it can be installed in a plenum without putting it in conduit. Right. However, there is no such thing as a plenum-rated stranded category cable. And that's because stranded category cable is used for the jumpers that go in patch bays. And as a consequence, the manufacturers are saying, well, it's never going to be installed in a plenum, so why go to the trouble of making a plenum-rated version? So if you wind up in the position where you have to use plenum-rated cable, which is solid conductors, and the devices that you're working with only have screw connectors, compression connectors, use a pigtail. Use, sometimes they're called jelly beans. There's a whole array of insulation displacement splices that are available, and just put a little pigtail on the end of that solid wire for where you terminate into your device. It's probably something you're going to come across at some point. So just do that and make sure that you're using the right type of wire, i.e. stranded, with a screw termination. If you terminate solid wire on a compression screw terminal, even if you're not blasting Metallica, it will eventually fail.
Yeah.
Unless it's 12 gauge.
I feel like we could certainly go down this rabbit hole and find the right circumstances, but I mean, it's just best practice. Don't solid core screw
category
terminal.
Cable. Yeah, don't. But not when you're talking 22 gauge. Nope.
Right.
Don't do it.
But at any rate, so I mean, we're almost out of time here, and I mean, this is good stuff. This is the nerdy stuff that personally I love getting really into the weeds on, and we could have gone for another hour, I'm sure, talking about this. I'm sure people would have fallen asleep by the end of that podcast, though. So I think this is a nice bite-sized piece for people to gnaw on. But to just quickly sum it up, I mean, ultimately, what we're talking about is permanent installation for DMX has been an evolving component within the world, because DMX is really originally designed for temporary entertainment style formats where you have 5-pin XLR jumpers to a degree. I mean, yeah, okay, there's debate to be made on the semantics of that, but for ESTA's purpose originally, it was like, okay, get everybody on the same page with a protocol and selling the same equipment and everything.
Very briefly, since you're going to provide a link to E1.68, there is a section on the history of DMX512 in the E1.68 document.
Right. Perfect.
Use the link at the end of this podcast and connect and read the history.
I don't need to go into the whole history of it. But anyway, so dealing with DMX in the permanent installation world has had some ups and downs to it, and it's primarily because of the fact that permanent installation has different requirements, different needs, different installation formats, and additionally, we don't have connectors on either end of our wires. We usually have terminals or some other way of terminating the cable, and so ultimately, it's just about figuring out how best to provide clear communication between devices that doesn't get mucked up through ground loops or other poorly designed things. So if you are unfamiliar with how to handle DMX512 on the cabling side of things, there is a standard, there's guidance, there are people out there who know what they're doing. Don't just make an assumption. Absolutely don't just go, well, I think I know what's going on here, so I'm just going to shove all my insulation onto pin 1 and be done with that, or I'm going to connect earth ground on both ends because that seems like a good idea. Like, do a little bit of research. Reach out to people. There are people who will give you free advice. You don't even have to pay people for this advice. So, like, just get a little bit more familiar, because DMX is growing in popularity in the built environment. It is a really powerful protocol. It has so many benefits to bring. And if you just study a tiny bit more, you can really provide an effective solution. And again, with the compliance standard now out, you can really vet the components you're buying and installing in your projects, so that way you know for sure that it is providing true DMX512 as opposed to some homebrewed version of DMX that might work under the right circumstances. So all of that is to say, definitely check out the links that we're going to have in the description to this episode. Learn more about what DMX has for availability of resources. ESTA is a great resource, and if this episode happens to come out ahead of Plugfest, I don't think it is, but if it does, and you want to go check out some even more dorky nerdiness when it comes to DMX and other things, check out Plugfest, which is going to be happening soon. But otherwise, ESTA, again, is just a fantastic resource waiting to be tapped into if you're unfamiliar with them.
And quite welcoming for people to come, either participate or be an observer on some of these standards groups. And when we put stuff out for public review, honest to goodness, even if you just read it and say you forgot the apostrophe on its or whatever, it just makes it better. The worst thing we hate is when we finally go through all the public reviews and we get a document published, and the very next day somebody says, you spelt color with a U. What are you, Canadian?
We have a lot of fun on spelling between the British members of the group and the American members of the group.
Yep, I'm sure. Guys, thank you so much. This has been great. I think, big takeaways for people, especially if you're an installer or you're providing stuff to your clients, whether you're providing to electricians or whatever. Copper is not copper. Don't let the electrician tell you that. That is not true. If you're an installer, the best thing you can do is provide the cable. Don't let the electrician do it. Just include it as part of your package. Provide the cable. That way you're going to get what you need. And then really pay attention to what you're using for equipment. What are you using on the front end for your control, your opto splitters? What are the fixtures requiring? It makes it really easy from the manufacturers when you're using opto splitters that output 1 could be a stranded wire, but output 2 could be a solid wire, just by using the connectors provided with the equipment and making sure that you have all the right parts and pieces. So do your homework, make sure you know what's connecting at the other end. So when you're telling the electrician to pull the cable, he knows that this one has to be solid, but this one needs to be stranded, and you can designate that out and provide the wire to make that really easy for them. So make sure
when you buy a third-party cheapo fixture, grab a multimeter and see if pin 1 is on metal.
Well, and that's going to be something I think that's will be interesting to see how this all shakes out with the compliance standard. And I know we've talked about this once on the show already, but there's a lot of stuff out there from Amazon and other big box stores that are definitely not compliant, that are coming from overseas. And it'll be interesting to see how this all shakes out with this compliance standard and how people notate that on their equipment or don't notate it on their equipment. So it'll be interesting to see that.
And the basic tests in the E1.68 compliance standard can be run with just a regular $5 multimeter. The more complex tests require more sophisticated equipment, but the basic tests can be run
available at Goddard Design.
Available Goddard design. And by the way, that is Goddard.design because we were able to get a design domain. So
Nice.
Oh, nice.
yes.
Good on you. Good on you.
Yeah.
Awesome. Well, Javid,
Thank you
Robert,
so much,
thank you
guys.
so much. Really appreciate it. I'll just close this out and remind everyone today's episode was presented by the LCA, the Lighting Controls Association.
And it's financially supported by the National Association of Innovative Lighting Distributors, or NAILD. Check out our website, lightingcontrolspodcast.com. We've got all of our episodes, including the episode that we recorded on ESTA's Plugfest and other great resources that we've already discussed before. But until then, thank you so much for joining us, and thank you, gentlemen, for joining us here. Really great conversation. So for those of you who actually listened all the way through the outro, you get an Easter egg. Javid, go for it.
So this is what I use to do a sound check because it's much better to use a natural speaking voice than to just go check, check, check to get a good level when you're doing a presentation. That said, 'twas brillig and the slithy toves did gyre and gimble in the wabe. All mimsy were the borogroves, and the mome raths outgrabe. Beware the jabberwock, my son, the jaws that bite, the claws that catch. Beware the jub-jub bird, and shun the frumious bandersnatch. He took his vorpal sword in hand, long time the manxome foe he sought. Then rested he by a tum-tum tree, and stood a while in thought. And while enoughish thought he stood, the jabberwock with eyes of flame came waffling through the tulgey wood, and burbled as it came. 1, 2, 1, 2, and through the vorpal blade went snicker-snack. He left it dead, and with its head he went galumphing back. And hast thou slain the jabberwock? Come to my arms, my beamish boy. O frabjous day, calloo, callay! He chortled in his joy. 'Twas brillig, and the slithy toves did gyre and gimble in the wabe. All mimsy were the borogroves, and the mome raths outgrabe.
That's brilliant. A true
Bravo.
thespian.
Bravo. All right. And with that,
if you do that for a sound engineer, you will be their friend because they will actually get a good level in your voice.
anyone who
All right.
sound checks, thank you so much, David. That was such a treat.
You're welcome. Thank you.